Your engine is being slowly choked to death. Not by a broken part, not by worn metal, but by a carbon layer thinner than a human hair. And right now, a $4 bottle sitting at Walmart completely dissolves that layer. No mechanic appointment, no $600 injector flush, no $1,200 replacement kit. I'm talking about a single bottle of the right liquid poured directly into your gas tank. It works inside 100 miles of normal driving. It attacks carbon at the molecular level while your engine runs. The auto repair industry charges $50 to $150 for a professional injector flush, and up to $1,200 per injector for a replacement. They push when it is completely unnecessary. A $4 bottle with the right chemistry does the exact same job. The industry prays, you never figure out which bottle that is. I'm going to tell you exactly which one and exactly why it works. The United States automotive repair industry generates $200 billion every single year. Fuel system service is one of its highest margin divisions. A dealership injector flush costs $50 to $150 in labor. The cleaning solution they use costs them under $8 wholesale. That is a 1,700% markup on a bottle of fluid. Here is how the trap is engineered. Modern direct injection engines, found in nearly every car built after 2010, spray fuel directly into the combustion chamber at high pressure, completely bypassing the intake valves. Older port injection engines from the 1980s let fuel wash over the intake valves on every cycle, naturally scrubbing them clean. Direct injection eliminated that self-cleaning mechanism entirely. Engineers knew this design would accelerate carbon buildup. They chose it anyway because better fuel atomization improved government emission test scores, and better scores sell more cars. Faster carbon buildup sells more service appointments. Both outcomes feed the same machine. Your vehicle warranty covers powertrain defects for 5 years or 60,000 miles. Carbon buildup serious enough to trigger a mechanic's recommendation typically appears between 30,000 and 60,000 miles, precisely at the edge of your coverage window. The warranty expires. Your mechanic says your injectors are coated. He quotes $150 for a flush, never mentioning that a $4 additive dissolves the exact same deposit. The psychological trap is flawless. Your engine hesitates. Fuel economy drops 3 to 8%. You feel afraid, and fear drives you straight into the service bay. The year was 1993. The Environmental Protection Agency was facing a crisis it had not publicly announced. The Clean Air Act amendments of 1990 mandated dramatically lower vehicle emissions by 1994. But carbon deposits on fuel injectors were causing engines to burn excess fuel, flooding exhaust with unburned hydrocarbons, and blowing past the new legal thresholds. The problem was entirely chemical, and the fuel industry had known about it since the late 1980s. The EPA responded in 1994 by requiring all gasoline sold in the United States to contain minimum levels of deposit control additives. Fuel companies began adding polyetheramine, known as PEA, to their gasoline at approximately 50 parts per million. The results were publicly documented. Injector deposits dropped, engine efficiency improved, and emissions fell. The technology worked completely. Chevron's Techron formula, built entirely on polyetheramine chemistry, reached the commercial market in the early 1990s. The American Automobile Association published independent research confirming these additives significantly reduced fuel injector deposits. But here's the criminal part. The EPA minimum was set at the lowest threshold that technically satisfied compliance, not at the concentration needed to clean deposits already built up in older engines. Budget gasoline brands met the legal minimum, but allowed long-term accumulation to continue unchecked. Your car drives 40,000 miles on minimum additive fuel. Carbon hardens on your injectors, mile by mile. At 50,000 miles, your mechanic calls it injector failure and charges $150 to flush what $4 of concentrated polyetheramine would have dissolved. That gap between minimum dose and effective dose has generated billions in unnecessary service revenue for 30 years. Do not close this tab. What you are about to hear is the chemistry they removed from every automotive service manual after 1994. This channel is a financial rebellion against a $200 billion system that profits from your mechanical ignorance. Every week, we expose the exact chemistry, the exact product, and the exact protocol that makes their most expensive services completely unnecessary. Coming up, the $3 chemical that eliminates the transmission, slip your dealer quotes at $2,800 to repair, and the $2 compound that permanently seals a leaking roof from the inside without removing a single shingle. Both videos are already filmed. If you're not subscribed, you're handing mechanics money they do not deserve. Hit subscribe and hit the bell right now. Every person who watches this channel instead of visiting a shop starves the system by hundreds of dollars it never earned. Stay locked in. The next 5 minutes contain the most important combustion chemistry you will ever learn without an engineering degree. To understand why a $4 bottle defeats a $150 service, you need to understand exactly what carbon deposits are. Every gasoline engine burns air and vaporized fuel at an ideal ratio of 14.7 parts air to 1 part fuel. At that exact ratio, combustion is clean and complete. But in a real engine, short trips, cold starts, and low-quality fuel mean some hydrocarbon molecules never fully combust. Instead, partially oxidized molecules, specifically olefins and aromatics, link together chemically into long, sticky chains. In their early stage, mechanics call this varnish. As engine heat bakes them further, they harden into carbon deposits coating the injector tip, intake valves, and combustion chamber walls. In a direct injection engine, the injector tip sits directly inside the combustion chamber and faces temperatures between 200 and 400 degrees Celsius on every single cycle. At those temperatures, deposits fuse permanently to the metal surface. The spray holes at the injector tip measure between 100 and 200 microns in diameter, far smaller than a grain of sand. A deposit layer just 5 to 10 microns thick reduces those openings by 5 to 10%. That tiny reduction completely destroys the injector's spray pattern, the precise fuel mist it produces 100 times per second. Without a proper spray pattern, fuel enters the chamber as large droplets that do not vaporize before ignition. Incompletely vaporized fuel burns late and inefficiently, dropping combustion efficiency by 3 to 8%. At 25 miles per gallon, a 5% loss costs 1.25 miles per gallon. At $3.50 per gallon over 15,000 annual miles, that silent loss drains $99 from your pocket every year with 0 warning lights triggered. The deposit also acts as a thermal insulator, trapping heat that accelerates further polymerization, more deposits growing faster because existing deposits are already there. It is a self-amplifying failure loop. The only signal you eventually receive is a check engine light showing codes P01171 or P01174, a lean fuel mixture. Your mechanic calls it injector failure and quotes you $600 to $1,200 for a problem that $4 of chemistry permanently solves. Polyetheramine is the weapon. Its structure is a long polyether chain, repeating oxygen-carbon-carbon units, capped with a primary amine group at one end. This combination of a flexible chain and a reactive tip is exactly what makes it aggressive against hardened carbon. It is sold in concentrated form as Chevron Techron Concentrate Plus, Gumout All-in-One, and Royal Purple Max Clean. A 20-ounce bottle costs $3.50 to $5 at AutoZone, Walmart, or O'Reilly Auto Parts. The moment polyetheramine enters your fuel system, it travels with the gasoline to every injector tip. The amine group attacks the acidic chemical sites on the carbon deposit surface, specifically the carbonyl and hydroxyl groups left by incomplete combustion. It bonds to those sites and neutralizes the electrostatic attraction, anchoring the deposit to the metal. The grip is broken at the molecular level. Simultaneously, the long polyether chain penetrates the deposit's interior, disrupting the internal molecular forces holding its structure together. The deposit fragments from within into small hydrocarbon segments that dissolve into the fuel, get carried into the combustion chamber, burn completely on the next cycle, and exit through the exhaust. After each combustion cycle containing polyetheramine, the injector tip is measurably cleaner. Then comes the second function. Once the metal surface is bare and clean, the polyether chain bonds directly to it, forming a protective film 1 molecule thick. This film is water repellent and chemically inert to combustion byproducts. New deposit precursors cannot bond to the protected surface. The deposit cycle is not just reversed, it is structurally prevented from restarting. Research through the Society of Automotive Engineers confirms polyetheramine treatment restores injector spray pattern geometry to within 95% of factory new specification in moderately fouled injectors. This chemistry has existed in peer-reviewed engineering literature since 1996. The repair industry has simply counted on you never reading it. The fuel system service segment alone generates $12 billion per year in the United States. A dealership charges $50 to $150 for an injector flush using product that costs them $10 wholesale, a 1,400% markup for 20 minutes of work. A dealership injector flush costs $150 and must be repeated every 15,000 to 30,000 miles. A $4 bottle of Chevron Techron treats 1 full tank and actively protects your injectors through the entire next service interval. A full injector replacement costs $350 to $1,200 per unit for a failure caused by a hydrocarbon film that $4 of polyetheramine dissolves in 100 miles. If just 10% of American drivers use this additive instead of paying for dealer flushes, the fuel system service industry would lose $1.2 billion annually. That is why these bottles sit in the back corner of the aisle with no staff recommendation. The equipment mechanics use exists to justify a labor charge. The chemistry does every bit of the actual work, and you can own the chemistry for $4. Here is the exact protocol. Follow every step precisely. Buy one 20-ounce bottle of Chevron Techron Concentrate Plus from the fuel additive aisle, not the oil aisle, at Walmart, AutoZone, or O'Reilly. Wear nitrile gloves during the pour. Total cost, under $6. Drive your car until the fuel gauge reads between 1/8 and 1/4 of a tank. This is the most critical step. A low tank maximizes the additive's concentration at the injector tips. A full 15-gallon tank dilutes it by 75% and kills its effectiveness. Pour the entire 20-ounce bottle directly into the tank. Do not split it across 2 fill-ups. Then immediately fill the tank completely at the pump, using 91 or 93 octane premium if available. A higher combustion temperature enhances the cleaning rate. Standard 87 octane works if premium is unavailable. Drive 100 miles at normal highway speed, 60 to 70 miles per hour sustained. Do not idle in your driveway. The cleaning reaction requires combustion under real load at full operating temperature, between 195 and 220 degrees Fahrenheit. Between miles 30 and 70, you may notice brief, rough idle or slight hesitation. That is fragmented carbon passing through the system. Do not stop. This is the chemistry working exactly as intended. After 100 miles, refuel using top-tier certified gasoline, Shell, Chevron, Costco, or Mobil, which contains above minimum polyetheramine levels required by General Motors, Ford, Toyota, and BMW. For severe symptoms, including misfire codes or fuel economy loss above 10%, repeat with a second bottle on the next 1/4 tank. 2 treatments, cost under $10 total. For ongoing prevention, add 1 bottle every 5,000 miles, roughly every oil change. Annual cost, $18. Annual dealer flush cost, eliminated $150 to $600. Net annual savings, up to $580 every year, for as long as you own the vehicle. After treatment, clear any stored fault codes with a $25 code reader from Amazon. Drive 50 miles. If lean mixture codes do not return, the injectors are clean. A third treatment resolves 95% of remaining cases. In 1993, the Environmental Protection Agency forced the entire American fuel industry to add polyetheramine to gasoline because carbon-choked injectors were poisoning city air. The industry complied at minimum dosage. The repair industry watched silently and built a $12 billion empire on the gap between that minimum and what your engine actually needs. For 30 years, that gap has extracted $150 per visit from every driver who simply did not know the chemistry existed. You now know it. A 1965 carburetor could be cleaned with a toothbrush, and a can of spray cleaner in 20 minutes on your own driveway. A 2024 direct injection engine fires fuel at 2,900 pounds per square inch through holes 100 microns wide. The technology became more precise. The financial dependency on professional service became proportionally more profitable. The 1965 mechanic handed you the spray can. The 2024 dealership hands you a $1,200 estimate. The technology advanced 60 years. The honesty traveled in the opposite direction by the same distance. Send this video to every driver you know. Send it to anyone who has been quoted hundreds of dollars for a fuel system service this year. Every person who watches, instead of walking into a service bay, removes $150 from a system engineered to exploit them. 1 million views cost the fuel system cartel $150 million in revenue it never deserved. The days of paying $1,200 for a film thinner than a human hair are finished. You have the chemistry, the protocol, and the history of exactly why and when they buried it. In the next video on this channel, we go after the transmission repair industry, a $28 billion cartel charging $2,800 to rebuild a gearbox that is slipping because of a $3 friction modifier deficit. 1 bottle, $3. They have hoped you would never hear those 2 sentences together. That video is coming.